Hi everyone, welcome back to workshop, and it's time for another repair. And I've managed to pick up a bench power supply. Bought it off of eBay. In actual fact, it was a manufacturer, Digimess, that was actually selling them. Now they're just cheap power supplies, single rail bench power supplies. This particular one's 0 to 60 volts at 3 amps. And the company that manufactured them, as I said, is selling them, and it's a faulty unit. And what they've said in the ad, that it's actually sometimes more cost effective for them to sell the faulty power supplies rather than have somebody in their workshops, an engineer, spend time to repair it. So this particular model, like I said, it's a 60 volt 3 amp model, PM6003. On Farnell they're selling for about £152. Now that is quite expensive for what's basically just a small bench power supply, and you can get them 10 to the dozen. Just every manufacturer's got them going around. So I thought I'd just put my hands in this one and see if we can get it up and running again. So how often they're selling faulty gear, I don't have a clue. The ad was just for one unit, and it looks like they've only got one unit. There's no other ads anywhere on eBay. This one's advertised as not powering up. So we're going to get down on the workbench here and see if we can't effect a repair. So I'm not going to power it up straight away because the ad says it doesn't power up. There could be anything wrong with it. There could be a mains wire inside, lying loose or something like that. So I really want to open it up and have a look and see if there's anything immediately wrong with it, and we'll take it from there. Alright, we've got the lid off, and the first thing that strikes me, yeah, it is a pretty light unit, and it's a switch mode design. It doesn't have a transformer as such inside it, and that's probably why they're able to just offload faulty ones, because quite a lot of the cost in a linear mode power supply is the transformer itself. So this one being switch mode, it's almost disposable to them if it doesn't work. So when I get in here, have a look around, see what we can find, and do some the checks before we actually power it up. So the first thing I had a look at was I double checked to make sure the fuse was alright in the back there, and it is, and it's selected for 230 volts just while we're at the back there. And you can see the mains AC comes in, goes away off straight to the power switch located on the front there, and then from there down onto the main board. So all the wiring looks intact, so I'm going to do some ohms measurements there just to see what we've got. But one thing I noticed whilst I was in here, on the actual control board here, I noticed that it's got a couple of daughter boards that plug in there, and they are actually quite loose there. This one here especially, if I can just get you in there to have a look. In fact, I'll zoom in. It's, they are pretty loose, so whether that's had any issue there, I don't think so, because you would still expect it to power up and do something, I would have thought. Maybe not in the display, maybe the display would be blank if there was a problem here with these plug-in boards. So I'm going to leave them as is at the moment, maybe just reseat them. Yeah, that one there definitely plugged in, but that could have been vibration due to shipping, right enough. And this one at the back here as well wasn't so bad, but definitely that one there had a problem. So you've basically got the control board at the back there, to zoom out, as you can see there with its daughter boards, and you've got an input power supply there, probably generating the high voltage down DC down onto the main board there. And you've got at the front here a display board using the good old ICL 7107s. They've been around for a lot of years, so that's what's controlling the display there. So wouldn't have thought there'd be any problem with that there, but we'll take a look. The next thing to check, I noticed there is a thermal switch down on one of the heat sinks at the back there. I think that's in the MOSFETs. So I'm just going to disconnect power there for a second and see if I can measure across it, just to see if it's open circuit or closed. And as you can hear, it's showing that it's closed, so that would be all good. You'd expect that if it's stone cold at the moment. I think the next thing I'm going to do is, there are these 3 wires here. If I just zoom in a little, there's these 3 wires here, this black and blue and red, come off the main power supply board and then down onto the main control board. That looks like that's the main DC down onto the main control board. Okay, Digimess did actually supply a schematic diagram with the power supply, so I'll just go through that now and show you how it works. It's a switch mode design. There is no large transformer, there's lots of small transformers. So starting at the left hand side, we've got 240 volts coming in, common mode choke and a bridge rectifier. So you're going to have 350 volts approximately DC across there. That interfaces to T202 via a couple of MOSFETs. The MOSFETs do the switching on the primary side of T202, the secondary side, which goes away off the rectifier there, and controlled via a large MOSFET, Q401, produces your output voltage. The primary side of 202, like I said, is controlled by a couple of MOSFETs there. There's a transformer there. The 2 secondaries drive the MOSFETs, and the primary side is interfaced to a TL494. That's a PWM chip, so that comes up via a couple of push-pull transistors there, up onto T201 on the primary side. The secondary side interfaces to the MOSFETs in order to drive T202. Over at the right hand side here, we've got the constant voltage and constant current op amps, etc. And obviously the front panel pots will be in there as well, and that interfaces to Q401. That's how the output's controlled, all via the one large MOSFET. Down at the right hand side here is a small power supply, because obviously the op amps, the TL494, etc. all need regulated DC power in order to work. So there's a small power supply here. You could call it a standby power supply by the fact it runs using a TOP226. That's quite well used in the likes of TVs, etc. In order to produce standby power, a low power supply. So you've got 350 volts coming in there again, onto T101, that's the primary side here. This side of the primary comes down here onto the TOP226, and you've got an S&D, source and drain. That's actually a MOSFET within there, so that's how the primary side of that transformer is switched. So T101's got 4 secondaries. Let's jump down to this one here, the 5 volts that goes away off to the display board. The display board circuit's not shown here, so that 5 volts is tapped away off, and via an opto-isolator controls the control pin of the TOP226, so it's self-regulating. And there's a 4th secondary here which produces the power for that control signal, because it's, like I said, it's opto-isolated from this one here. There's another 2 secondaries here, J2, which goes away off to J5 over here, so that's TL494 power. Then we've got another one here that goes away off to J7, that's the power for the op-amp circuit, etc. The only other part of the circuit is this couple of transistors and a Zener diode, etc. here. That interfaces to the control pin of the TOP226 as well. And what this little circuit does is basically it's a soft start or a delayed start. As the power supply is switched on, this transistor here will hold the control pin down low, and it's not until this 350 volts across here is up above, say, 300 volts, something like that, that this transistor will switch off. So it's just a bit of a delayed start, soft start. So I think the first thing we'll do is look at the power supply. We've got a couple of caps there and a bridge rectifier. Let's have a look and see if we're getting a nice big unregulated DC at the bridge rectifier. Okay, you've got to be careful here. We've got some rather large voltages here, so we'll just try and get on to the bridge rectifier. I can get in pretty safely here, I think. And yep, we're getting 340 volts DC, so that's fine. So I think the next thing I'm going to do is I'm going to jump straight to the 3 wires that go from the main power supply onto the control board, and let's see what we're getting there. Right, so very careful once again. So I'm getting 170 volts DC on one of them, and on the other the full 340 volts DC. So the next thing I'm going to do, I'm going to jump actually straight onto T202, and let's see if we're getting an unregulated DC output at Q201 there, or across C203 is probably a better way to do it. And that large electrolytic there, that's C203. So we'll just go on to the back. Be very careful here because, well, the power is on now. It was on before, but let's take a look. So let's take a look there. So without touching it, those two pads there, that's C203. So once again, let's see what's across that. Nothing. Absolutely nothing. So what that's telling me is that probably T202 is not operating. So a little bit more of an investigation there. I think the problem lies down here. I'm certainly not getting anything out here, and I'm not getting anything across that primary there. There's no switching going on there. So I need to do a little bit more of an investigation there. I think I'll pull the board and sort of look a little bit of a closer look at some of these components here. Right, we might be getting somewhere. I did a little probing offline there with the power off, just with the multimeter and ohms, and just checking out some of the diodes and resistors around about here. And we've got a little TVS diode here which seems to be suppressing, you know, spikes and transients coming through from this high voltage here onto the primary here, which you obviously wouldn't want to make its way through onto the secondary. So probing around here, just checking out the diodes, and this one is measuring way off. In ohms it's almost a dead short in both directions there. Let's take a look at the multimeter here, and I'll just try and do that. So that's D102. So let me just zoom out a little and get the multimeter in shot there. There we go, and I've pulled the diode from the PCB at one side just so I'm not getting any interference from any other components that might be upsetting the readings there. So I'm in ohms on the multimeter there, and let's see, there we go, 18 ohms, 14 ohms on that diode there. So I do think there's something wrong there. I'm not getting any shorts. I put a bit of paper underneath the PCB there, so I do think there's a problem there. The other diode that's in series with it is just a normal 4005. It appears okay. Obviously it's not in circuit now because I've lifted that TVS diode, but if I just go across it there, I'm getting, I don't know if you can see that, I'm getting like 0.5 a volt, 0.6 of a volt in one direction, and the other way, let me just see if I can get onto it again there. Yeah, I'm not getting anything, so I think that other diode's okay, but I do think there's something wrong with this TVS diode there, so I think I'll change it out and see how we go for here. Okay, I've bolted the power supply back in place and put the cables back in, the connectors, just two screws holding it in where the earth tabs are on each opposite corners of the board there. So let's see if it works. Yes, we've got power. Brilliant. No magic smoke. And we've got some displays there, so let's have a look. I've got a constant voltage mode LED showing, that'd be right enough, and the voltage pots are at the side, coarse and fine. So let's see what happens if I up the voltage one. Yes, excellent, and it's a 60 volt power supply. Oh, it went off. Wow. Okay, so what happened then? I screwed the coarse adjustment right up to try and see if it would reach 60 volts, and it appeared to be, when I hit that, it cut out. Well, let's have a look at the power supply again. Okay, so what I found was that the Schottky diode and the TOP226 were fine, certainly not dead short or anything like that this time around, and I couldn't really find any more damaged components on the power supply. I did investigate it. I basically took some components out where I needed to, and beeped them out, checked them, and it all seemed okay. I even went as far as taking this transformer T101, took it out and made sure there was not any leakage from one winding to another, and it's not the case. And so I powered back up again, and I looked at the voltages on the output, the secondaries on the transformer, and to tell you the truth, they're a lot higher than what they should be. Although I wasn't getting any display, I was still getting some output on the secondaries, and in fact I pulled the connectors. Let me just bring up the schematic there. I did actually go and pull J2, J3, J1 off of the power supply, so it's basically just isolating it more or less. And J1 is supposed to be a 5-volt output. I was getting 9 volts. J7 was way up, a lot higher than what it should be, as was J2. So there's clearly some sort of over voltage going on somewhere. So I spent some considerable time, a couple of hours actually, going over the various parts of this circuit and how it operates, how the 226 operates. And I really wasn't happy, to tell you the truth, in how the circuit's hooked up with the opto-isolator. What you've basically got here is this 5-volt output is generated, because if you look closely, there's the positive side after the rectifier diode goes through here. You've got a forward bias diode in the opto-isolator, then you're straight on to 3.9 volt Zener, and then a 100 ohm resistor down onto the other side of the 0 volt side effectively of that winding. So 3.9 volts plus about the 1.2 volt volt drop on the opto. That's what's actually clamping the output of this secondary down to 5 volts or thereabouts. But I was getting 9 volts. I was getting more than 3.9 volts across the Zener, and I was getting quite a volt drop across that 100 ohm resistor. So I really wasn't happy, and what I've kind of determined from that is that the TOP226, this circuit wasn't starting up properly, which was causing all the outputs to just go sky high. Just wasn't happy with it at all. So I compared this part of the circuit here with the Zener, the opto, and that resistor there. So here's the modification I went ahead and did, straight from the TOP226 datasheet. I've got the positive side after the rectifier diode there going on a 2.7 volt Zener. The other side just goes via 100 ohm resistor straight to the negative side. Basically, the opto-isolator is not in that loop. It's seriesed off with a 10 ohm resistor through the opto and then down onto the negative side. Now I've chosen a 2.7 volt Zener to generate about 5.25 volts on the output there, and I'm just letting the opto-isolator do its own thing. So yep, once I did that, straight away I was getting my 5.25 volts, and I was getting a much lower voltages on the output of the other two, about half of what they should have been. I had to act quickly on that high voltages there, because these two voltages here were actually above the electrolytic voltage. This one here is 63 volts. I was getting about 90 volts out of there, and this one's at 35 volts. Well, I was getting about 24 volts output there when it should be about half that. So as soon as I'd modified this circuit, got it down to 5.3 volts, these ones fell into place, and as did this secondary here. After I did that, it seems to be a lot more stable. I don't know what was wrong with the original design. Perhaps it was a startup problem, perhaps a design problem, I don't know. But just as soon as I went to the datasheet example, everything fell into place and it started working again. So that's the power supply back in place with the modifications made. They're all in the undersides, you can't see them, but I'll put up a photograph there of the underside so that you can see the modifications I've made. Also notice the electrolytics have changed. you know, I don't know how long that high voltages were appearing across those electrolytics, so I did actually go ahead and change them out. I did that after the fact, after I knew the power supply was stable, so it's just a bit of a precaution. There's actually another electrolytic down there that I've changed as well, so I've changed 3 in total, just for reliability and just in case there's any, you know, wear and tear being acted upon the old electrolytics. So everything seems to be working again. If I just turn it round there and I can power it up. So I've connected up my multimeter here now so I can demonstrate the output working. So I'll put the fine control right up and then I'll start screwing the course all the way up. 60 volts, 60.6, 61 in the output there. That's good enough. And right down to the bottom end. Takes a little bit of time, seems to be damped quite heavily. And it should go all the way down to 0. .5, 0.4, yeah, on its way. And then back up again. The coarse pot is quite coarse given the range. Oh, multimeter's off. The range is going across 0 to 60 volts, so the slightest tweak in it does seem to make it jump by quite a few volts actually, so I suspect that it's probably even going to be susceptible to a bit of shock. So 25.3, yeah, I did see it jump down there to 23 then back up again, so that's probably the pots. So I guess the next question is, does it actually work under load? It's a 3 amp power supply, so let's go straight to 3 amps at 32 volts. So I've got the external electronic load hooked up here and I've still got the multimeter in parallel with that, so let's just go straight. I'll just turn on the load now and the constant current controls kicked in, I see. So I'll just turn off the load, back to constant voltage mode. I'll turn the coarse and fine right up and then try 3 amps again, and there we go, 3 amps at 32 volts. So obviously I've still got a good bit of testing to do, just make sure it's stable and all the rest of it, but I think we'll call that a winner. Thanks for watching.